Welcome to Ship It, the course where we take a model out of the notebook and put it on the internet where real people and real systems can call it. Here's the promise. By the end, you'll have shipped a model that's reproducible, served behind an API made fast, and able to retrieve facts it was never trained on. And you'll understand every line that got it there. We move through 5 stages, and each one closes a gap that the notebook left open. First, we package the model with MLflow. So what you ship is exactly what you trained. Then we serve it with FastAPI and Gradio, so it answers calls instead of cells. Then we optimize with ONNX and vLLM, so it's fast enough that nobody waits. Then we retrieve with embeddings, FAISS and Weaviate, so it can look things up. And finally, we build graph-rog retrieval over a knowledge graph and ship the whole thing as a capstone. The discipline here is simple, and I'll hold to it the entire course. Real code in a real environment, seeded so the numbers come back the same every time you run it. And on the 2 days we touch a tool that physically can't run offline. I'll say so out loud and show you genuine current API with an honest caption. Never a mock dressed up as a real run. Everything you see on screen, you can rerun. That starts now, episode 1. This is where the course begins, so there's no callback yet. Just one question. You've trained a model, the notebook says it works, the metric is good, so why isn't it shipped? The answer is that it works in my notebook and it's in production, are separated by 5 specific gaps, and today we name all 5. A notebook has no contract. You hand it a tidy array you prepared by hand, but production gets a raw HTTP request from a teammate who doesn't know your column order. And a model with no input schema will happily predict on garbage and return a confident number. A notebook has no server. Your model lives inside one Python process that dies when you close the tab, but production means another machine can call it at 3 AM while you're asleep, and a function that only exists in your REPL can't answer a phone that never rings to you. A notebook has no record and no speed budget. Nobody can tell you which model version produced last Tuesday's prediction because nothing was logged, and nobody measured how long predict takes because in a notebook a few hundred milliseconds feels instant until 1,000 users hit it at once. And a notebook has no knowledge beyond its weights. The model knows only what it saw in training, frozen on the day you fit it. Ask it about a document written yesterday, and it has no way to look. 5 gaps: contract, server, record, speed, knowledge. The whole course is closing them one stage at a time. Let's make this concrete instead of abstract. We'll train a tiny model, save it to disk with joblib the way you actually would, load it back in a fresh function, pretending we're the server, and call predict. Then we'll deliberately poke each gap and watch the model fail to notice. First, we fit a logistic regression on the seeded iris dataset and dump it to model.joblib. That one joblib.dump line is the entire save step, and it's the seed of everything we'll formalize next episode. Notice we also record the model's end features in .os, which is the only contract it carries, a bare count of how many numbers it expects. Now the key move, we joblib.load the file into a function that has no idea how the model was trained, because that's exactly what a server is, a stranger with a saved file. It calls model predict on a clean sample and gets the right class back. So far so good. The happy path always looks fine. Then we break things on purpose. We feed predict a row with the features in the wrong order, and it doesn't raise, it just returns a different wrong answer with the same confidence. We try a row with too few columns, and only now does it error on shape alone, never on meaning. That silent wrong answer is the missing contract. Live on screen. Run it. The model loads, reports it expects 4 features, predicts class 0 on the in-order sample. Correct. The scrambled order sample predicts class 2, also confidently. and it's wrong. The malformed sample raises a value error about shape. We print gap, no schema, no server, no log, because nothing here validated input, listened on a port, or wrote a record. The figure says the same thing the terminal does. The card shows the round trip, train, save, load, predict, and a checklist of the 5 gaps with the 3 we just demonstrated marked in red. The predicted classes on the card match the terminal exactly, 0 for the good row and 2 for the scrambled one. Production isn't a server, it's the 5 promises a notebook never made. Next episode, the model artifact. We replace that bare job lib dump with a proper packaged artifact that carries its own signature, dependencies, and version.